That's the first part of the thread cut. Now I can put a decent recess in here for my screw cutting tool to drop into, so I'm not going onto a blind shoulder. Need a little bit more blade sticking out of there. Plenty of clearance there. Just another way of making sure that the screw cutting tool is at 290 degrees to the job, which it is there. We know it's on centre height. Just going to touch it off, put some cut onto it. Right, that's the lead screw engaged. Same with that thread. Once it starts, I can't disengage the lead screw. This should be about the last cut. We're looking to take just a funny hair off the crown of the thread. One row on the same setting, and that's going to have it absolutely spot on. This is spring cut's going to take it right down to the dead on size. That's it, perfect, or as near perfect as I can get something. A little chamfer at the end of each thread. I need to drill in for, say, 65mm, just so I don't scrap that piece of bronze, that's all. I've drilled the hole through and stopped there, and that piece is still usable for something else. Right, I've drilled that to the same size as the original hole. Now that one's teardrop, that's obviously way with just the water and the shite in the water running through it. I've used this method before and it seems to work quite well. It's just a little bit time consuming. It's basically a bit of high speed steel sharpened like a chisel point, and all you do is feed it in by hand. And you could use a file, just do this with a file. Right, it's not perfect, but it's certainly got a square in, and I'll make them a little tool to go in there, probably just a bolt with a square mill on it to go in there. You'll be able to use that to tighten it into his boiler backhead, no problem at all. I've got a badly damaged carbide milling cutter in there, but that part of the cutter's alright, so it should do what I wanted to do. I'll just touch it off first. Right, we'll zero the DRO. I would think it'll probably take all three in one go. I'll dial 2mm in, and then we'll see what sort of result we get from that. Didn't like it. Sort of going to one. This is a high tensile spool and a blunt cutter, of course. Three sides done. Here's the last one. The fitting standing on a piece of nice soft aluminium. It is a decent fit in there, we'll just make it a good fit. So that's brushed its way into there quite nicely. Once we get that out of there, it's going to be ideal for tightening it in. You can put your Silsons on there, even put 2 nuts on. So we've got the fitting and the purpose made tool for installing it. Right, that's it. It does fit 4 ways. Just fits better one way than it does the other 3, but I'm sure that'll do the job. Stilson's on there, tighten it in. so I'm making it happen. That's right. Guess what it's going to be yet? I've been asked by a lot to work off if I can make them 8 of those. I don't like doing production work, but it always puts a few pennies into the shop. So what I've done, I've made the 8 of them. It's basically a bit of 12mm stainless steel with 6mm threads in each end. Right, so I've done them. Obviously I can't show them being made because they're already made, but what I need to do is make 4 that are 50mm longer. I've cut the blanks off from the stainless steel, just sit them off with an angle grinder, probably left a couple of mil on each end. Now the way I'm going to go about these is a way to reduce the amount of processes you actually do to make them, just to try and speed things up a little bit. The first thing I'm going to do is get them to length. So they need to be 50mm longer than these, so we'll measure one of these are all the same length, plus or minus probably 1/10 of a mil. If we zero the vernier there, zero, add 50mm on, zero that. So when the vernier shows zero, they'll be the right length. Right, the first thing I'm going to do is machine one end square, just dress it up. This chuck won't accurate enough for what these need to be. Right, so we've got one end squared up. While it's in the chuck and still spinning, I'm going to centre drill it as well. Right, we'll turn it round, square this end up, and I'm going to measure it. We want the vernier showing zero when it's at the right length, and it's showing 5.8, so we need to take 5.8 off there to make that the right length. So one end has already been machined flat with a centre drill mark in, so I'm not going to do the other way around. Just going to touch this off. Right, so I want 5.8 off there. We'll use the DRO. There's 2, 4, 5.5, 5.8. Right, so that should be down to length. Next thing we'll do, centre drill it. Right, so that should be one bar at the right length, which it is. It's actually 300ths of a mil on that side, but for what these are for, that's absolutely spot on. So I'll do the other 3, get the other 3 to that stage. Right, the next stage of the job, back in the chuck again. Going to put a little chamfer on the end, like that. I'm going to drill the hole. It's a 5mm hole. I'm going to drill it to a depth of 20mm. And I got 15mm thread in there. Right, that's 20mm thread. Turn it over. Right, so now we've got that drilled both ends. I will do the other 3 exactly the same as I've got the tooling set up. Right, next thing is to put the threads in. Slow the lathe down. I'm going to power tap these. Just using the calibrations on the tailstock. Right, that's it, 15mm thread. Reverse the lathe. Throw it out. And turn it over. basically that's that one finished, and the other 4 are ready to take to trade. That's how I would make them. A little bit of production work. The caps and lathe will be quicker. The CNC lathe will be fantastic, but for the amount I'm doing, I'm quite happy to do it that way. As usual, I'd just like to say thanks for watching, thanks for subscribing, and as always a massive thanks for all the welders that are coming in. Anyway, thanks for watching.